So in terms of proving, again, what we normally like to do is start with the side that looks worse and try to make it look like the side that is simpler. So in my mind, it's this guy here. So we basically have the cosine of 2x minus the sine of 2x squared. So that's essentially a big FOIL problem. So we have the cosine of 2x minus sine 2x times the cosine 2x minus the sine 2x. So if we FOIL this out, we're going to get a cosine squared 2x minus sine 2x cosine 2x. Inner is going to give us another minus sine 2x cosine 2x, and then last times last gives us a positive sine squared 2x. And so if we clean this up, cosine squared plus sine squared, it doesn't matter what the angle is, but we know that cosine squared plus sine squared is equal to 1. And then we have a negative sine 2x and another negative 2 sine 2x. So we have minus 2 sine 2x cosine 2x. So far so good, right? We at least have the 1 minus. Here though, what we have to do is we're looking at 2 times sine cosine. And so our a in this case is equal to 2x. So this piece right here is 1 minus the sine of 2 times 2x when we use our double angle formula, because that's basically what that is for sine, and that results in 1 minus the sine of 4x. And so we basically have proven my result that I want. Alright, so there you have that one. Okay, so we're off to the races. So again, the next one, I'm going to obviously 1's the most simplest version, so we definitely want to start on this side. So how about we begin by rewriting this. We're talking about 2 tangent of x. Cosecant is sine, so we're talking about sine 2x, and then minus tangent squared. Alright, so what can we do next? Well, maybe we rewrite tangent. Well, I won't do that just yet. Now let's go ahead and do that. So tangent, right, what we have up in the numerator is 2 sine x cosine x. And what we have down this denominator, sine 2x, is 2 sine x cosine of x. And then we're still subtracting the tangent squared. So what do we have here? Well, for starters, I notice that the 2's, they cancel out. All right, we have a 2 up in the numerator, we have a 2 down in the denominator. And looking at what's left here, right, this is all over 1. So if we took this fraction and divided it by this fraction, what we're essentially looking at is sine x cosine of x multiplied by the reciprocal. Okay, I see that the sines go away and we're left with 1 over cosine squared x minus the tangent squared x. Well, 1 over cosine squared, that is secant squared x minus tangent squared x. And we're almost done here. Let me write it in red, because we know from our Pythagorean identities that tangent squared x plus 1 is equal to secant squared x. So if I subtracted this, we know that 1 is equal to secant squared x minus tangent squared x. So if we rewrote that Pythagorean identity, this is basically equal to 1. Alright, so there you have it. So a little bit of I rewrote using a reciprocal identity, I rewrote using a double identity, I rewrote writing sines and cosines. Algebraically, I divided my fractions, and then as I continued to simplify, at this stage I saw a Pythagorean identity that I can rewrite and go from there. Alright, so not too shabby. Okay, so the last one that we have to do here, again, it looks like the left-hand side is a little bit tougher than the other side. So why don't we begin by rewriting what we know about tangent of 2x. Maybe that's a good start. So this is 1 plus the tangent of x, and we know this to be 2 tangent of x, 1 minus tangent squared x. Alright, and so let's see where this leads us to. So we have 1 plus, this is 2 tangent squared x all over 1 minus tangent squared x. Getting a common denominator, what we basically are looking at here is 1 minus tangent squared x, and then we're going to add 2 tangent squared x, and this is going to get us all under the same denominator. So I just rewrote this 1 as this thing over itself, and then I basically combined my fractions together. So if we take a look at this, we're basically looking at 1, there's a minus tangent squared plus 2, so we're looking at 1 plus tangent squared x, right, all over 1 minus tangent squared and x. Okay, so I know definitely the top, right, that top is definitely secant squared, right? So we have a secant squared x, and then the bottom, let's see what I can do with that. How about, what can I do with that sucker? So we have secant squared x. What can I do with that? Where can I go with that? So secant squared x, 1 minus tangent squared. How about I rewrite that? If I come back to here, well, let's do this. Let's go ahead and rewrite everything in terms of its sines and cosines. That's drawing a blank. So this is 1 plus sine squared x cosine squared x all over 1 minus sine squared x over cosine squared x. And at this stage, what I'm going to do is I'm going to invoke that trick to clear out my fractions that are everywhere. How about I multiply both top and bottom by cosine squared x, and I'm running out of room there. But if I multiply the top and bottom by cosine squared x, if I distribute up here, I get cosine squared x. The cosines will cancel out, leaving us with plus sine squared x. On the bottom, we got cosine squared x minus the sine squared x. And I think we're off and running here because upstairs we get 1, right? So I'm kind of running out of room here, so let me bring it up here. So cosine squared plus sine squared is 1. And then what do we know about cosine 2x minus sine 2x? Well, that's our cosine of 2x. Using our reciprocal identity, there's our secant of 2x that we're looking for. Okay, so hey, so even I got stuck there a little bit, and so I changed course, and in changing course, I found I just rewrote everything in terms of sine and cosines. I multiplied top and bottom by the same thing to clear out the fractions, and that did the trick. So that took us where we wanted to go. So there is basically some proving of trig identities. Again, it's not an easy task. It takes a lot of work. You don't learn by just watching me do it. You got to kind of dive into it. You got to struggle. You got to conjecture. You got to, ask questions, whatever the case might be. And so that does wrap up section 5.5, our double angle formulas, using them to find exact values, using them to rewrite expressions, and using them to prove identities. Dive into that homework. Share your ideas on Canvas. See me during an office hour. Whatever it takes to help you learn those skills for our double angle identities. Talk to you guys later.